Or the lab. Okay.
Yes, sir.
Is it there, fuse?
Yes, sir.
Okay. You take battery. Okay.
Yes, sir.
So you take a fuse. Okay.
Yes, sir.
You can see inside of that fuse what is there.
Some wire is there, sir.
Yeah. Okay, some wire is there. Is it?
Yes, sir.
Okay, this is how our home circuit works, right?
Yes, sir.
One bulb. This is the voltage source. And this is the fuse.
Yes, sir.
Now what happened? Hello?
Sir, fuse broke, sir.
Broke. So in this situation, does the bulb is glowing or does the bulb glow?
No, sir.
No. Why?
Sir, because the wire is broken.
So wire is broken, current is not flowing.
Yes, sir.
So there is no continuity. This is called continuity. There is no continuity, right?
Yes, sir.
This happened. Why? Why this happened? Okay, I start once again afresh, right?
Yes, sir.
Okay, just watch. I take a new fuse. This is how we really do, right? This is the fuse.
Yes, sir.
Okay. Now, there are multiple fuses, right?
Yes, sir.
What is its tolerancy? Now I am reducing the tolerancy, means the current that it withstand. If more current is flowing, then it will break up, right?
Yes, sir.
Up to 1 ampere current. Now that it can tolerate 1 ampere current. So it is, the current flow is less than 1 ampere. That is why it is able to tolerate, right?
Yes, sir.
Okay. Now I reduced further 0.9 ampere. Still it is working, means the current that is flowing in the circuit is still less than 0.9. Okay.
Yes, sir.
Now what happened?
It broke.
It broke, means
Which
the
means
current,
the current tolerance is maximum.
yeah, current that is flowing through the circuit is greater than 0.8 ampere, right?
Yes, sir.
Okay, that you verify. Now I am, but I cannot take this one, so I go with, instead of this, now what I do is I take a switch so that I can connect it through switch. Okay. Now instead of this, what I do is I take only 0.9. Okay.
Yes, sir.
Now this is working. I verify this one, whether the current flowing through the circuit is exactly 0.9 or less than 0.9 or greater than 0.8 ampere or not. That I want to verify. Now I am verifying. What is the current?
0.89 ampere.
0.89. That is the reason why. So the fuse is still working. Why? Because the
Yes,
current that is flowing through the circuit is less than its capacity or its higher value of current. Got
Yes.
it?
Yes.
So you have to choose the fuse in such a way that it should be a bit higher than the current that is flowing through the circuit.
Yes.
Got it?
Yes.
Okay, that is the purpose of the fuse. Suppose sometimes because of increase in the voltage, that is called surge. You might have heard about this word.
Yes.
Surge or spike in the voltage. Sometimes if that happens, what will happen? If voltage is increased, what will happen to the current in the circuit? Increases or not? We know very well. From Ohm's law, we know already that when voltage is increased, resistance is not changing, definitely current is getting increased, right?
Yes, sir.
So when voltage increases, current also increases because we are not changing any bulb or resistance or wire or whatever it is. We are not changing them. So current automatically increases. When current increases, if some fuse is there, what will happen? If that current is greater than the current that can tolerated by the fuse, definitely that fuse gets burned, right?
Yes, sir.
So you have to choose such that the fuse should tolerate just above the current that is flowing through the circuit, so that when a bit more current is passing, that fuse blows away, right?
Yes, sir.
So you cannot put any arbitrary wire inside of that fuse. There are standards, right? There are standard fuses. 1 ampere fuse, 2 ampere fuse, 3 ampere fuse. Suppose I have one fan in my home, right?
Yes, sir.
Okay. Can it go beyond 1 ampere? No,
No,
it
sir.
can't go beyond 1 ampere, right?
Sir, in houses also this limit will only be, sir.
Yes.
In daily life also this limit only, sir.
In daily life,
The same limit, sir, 1 ampere.
that's what I am telling now.
Yes.
For some of the devices, suppose for example, you take fan, right?
Yes, sir.
Okay, what is the current that will be taken up by the fan? How you calculate? We discussed so many things.
Yes, sir.
Okay, how you can relate? What is the power that is drawn by that fan? Most of the fans
10 amperes.
are
100 watts
100
per hour.
100 watt. What
Yes.
exactly this mean? This is the power consumption by power means we discussed this one, I square into R, right?
Yes, sir. Yes, sir.
I square into R is equal to 100 watt. So what is its resistance? If you know the resistance, or if you know the current, you can find out the resistance. Or if you know the resistance, you can find out the current, the maximum current that will be flowing through the fan, right?
Yes, sir.
So current depends on the device, isn't it?
Yes, sir.
Why? Why the current? Because
Because
in
each one has
home,
their own specification.
yes,
Each device has its own specification.
no, not only that one. Okay, you just recollect, we already discussed the important points. I am putting here the resistance. Distance can be replaced with the device, right?
Yes, sir.
Because each device has its own resistance. Okay.
Yes, sir.
Now I am putting 3 resistors, means 3 devices, just like fans. In home circuitry, each device is connected in parallel, right?
Yes, sir.
Okay. Here I am connecting the voltage source, right?
Yes, sir.
Okay. Which one gets divided, current or voltage?
Voltage, sir.
So you forgot all the things.
Current gets divided, voltage remains the same.
Yes, this is the parallel combination of resistors. In such situation, voltage remains the same, but there is change in current or currents get divided, right?
Yes, sir.
So this is fan. Fan is having some resistance. So the current through that fan is different. This is another fan. It may be having slightly different or whatever it may be. That is current divided. So total current is I is equal to I1, right?
Yes, sir.
I use the same activity, same tool, and then I explain
Yes,
the
sir. Now
total
I'm
current.
remember. I remember now.
Yeah. I is equal to I1 plus I2 plus I3, right?
Yes, sir.
So now I connect a fuse here. This is the indication, right?
Yes,
Fuse.
sir.
Okay, fuse. Shall I connect fuse in parallel or a series? This fuse should be connected always in series, right?
Okay.
Why? Because if it is blowing out, definitely the circuit or the devices should not work, right?
Yes, sir.
That is the condition. The main purpose of using the fuse is when it blows. When does it blow?
When there is too much electricity out.
Yeah, when there is increase in the current, that current cannot be tolerated by the fuse. Okay, now combined the current, total current is I1 plus I2 plus I3, right?
Yes, sir.
Okay, current, suppose this fan is using 1 ampere, okay? This is 1 ampere, right?
Yes, sir.
This device is using 0.5 ampere, okay? And this
Yes,
device is using 2 ampere, right?
Yes, sir.
Okay, what is the total current? 2 plus 3 plus 0.5, right?
Yes, sir.
So the total current is 3.5 ampere. Now, what is the current rating for the fuse? Or how much current it should tolerate?
2.4.
3.5 or less than 3.5?
Less than 3.5.
Less than 3.5.
Yes, sir. 3.5 and more it cannot tolerate.
So greater than 3.5, it should have. At least it should have 3.6 or 3.7, right?
Yes, sir.
Otherwise, this second device or all the devices combinedly, they cannot work. If it is just 3.5, it will blow away, right?
Yes, sir.
Because one device is using 1 ampere, second is using 0.5 ampere, third one is using 2 ampere. We are not putting for each and every one, we are not putting one fuse, right?
Yes, sir.
We are using one fuse for all the devices, right?
Yes, sir.
Okay, suppose I will show you another way. Suppose I am using one fuse here. I am using second fuse here and I am using third fuse here, right?
Yes, sir.
So in this case, I can use different rating fuses, right?
Yes,
Because
sir.
this is the maximum current that is drawn by this one is 1 ampere. So I can use here just slightly greater than 1 ampere or maximum 1 ampere, right?
Yes, sir.
So I can use 1.5 ampere here. The second one is using 0.5 ampere. So I can go with 1 ampere fuse, right?
Yes, sir.
Because this is using 2 ampere, I can go with 3 ampere fuse, right?
Yes, sir.
So now I am using 3 different fuses at 3 different locations. So sometimes we may not use such fuses, right?
Yes,
At
sir.
homes. But industrial, or if you go to any industry, they will use such fuses so that they will protect the devices, right?
Yes, sir.
Because this is a 2 ampere current. Sometimes if this will flow, sometimes it will flow through this one, this device will get damaged, right?
Yes, sir.
So it all depends upon the protection that you want to provide to the devices, right?
Yes, sir.
So is it clear now?
Yes, sir. Now it's clear.
So first thing is you should remember is in homes or in houses, the circuit is parallel in nature, right?
Yes, sir.
Parallel. If circuit is parallel, the current is sum of all the currents, right?
Yes, sir.
Whatever may be the device. Suppose you take a one fan, one electric geyser, and one washing machine. Each one is having its own current.
Yes, sir.
Fan is using very less current. It may not go beyond 1 ampere.
Yes, sir. Sir, you are not audible. Sir. Sir, you are not audible, sir.
Hello.
Yes, sir. Now you are audible.
Okay. Am I audible?
Yes, sir. Sir, again you are not audible. Sir.
Am I audible?
Yes, sir.
Okay. Just internet got disconnected.
Yes, sir.
Okay. Are you able to see the screen?
Yes, sir.
So the total current. Suppose you take fan, its current rating may be 1 ampere. Okay. If you take electric geyser, the maximum current we use, sometimes we use 16 amperes. Okay. And AC, if you take, it uses 16 amperes, right?
Yes, sir.
So in that case, you need to be careful. So what is the fuse? It may be of 16 amp current, right?
Yes, sir.
Because the maximum current that will be drawn is AC or electric geysers, right?
Yes, sir.
So most of the people, what they do is they separate these devices from
Other
the
device.
devices which are using less current, right?
Yes, sir.
This is called circuit breakage. If you observed wiring, house wiring or home wiring, definitely it will, or you can understand now.
Yes,
Now I
sir.
can have 3 different circuits. I can connect all the circuits which are having only 1 ampere to 3 ampere maximum, right?
Yes, sir.
That way I connect. So I connect all the devices which are using more than 6 amperes, right?
Yes, sir.
That means I will connect in this, I connect only the electric geyser, right?
Yes,
In the
sir.
third one, that is AC, right?
Yes, sir.
AC is always connected only one. So in this circuit, I will be having only AC. I won't connect any other device. So like this, that circuits are divided, number of circuits. Okay.
Yes, sir.
So this is one set of tools. This is another circuit. This is another circuit. Once again, all these are connected in parallel once again,
Yes,
right?
sir. Yes, sir.
But they use one fuse to separate, right?
Yes, sir.
Got it?
Yes, sir.
This fuse, nowadays these fuses are not using. Now they are using MCB. You
Yes,
might
sir.
have seen, right? Heard?
Yes, sir. In houses it will be
Yeah, there will be
one small
a,
panel.
yes, you can just push up the switch or push on. You may be seeing that main board. If you look at the main board, right, you will find MCBs. One MCB will be with red color, others will be in green color. That red color one is called the main circuit breaker, main MCB. Okay, that is connecting
Yes,
the wire that is coming to our home, right? So that is a complete full details. If you want, it will take almost 1 or 3 or 4 hours, or it will take 2 or 3 days, right? That's a
Yes,
complete
sir.
different story, but that much detail is not there for you. You can
Yes,
just
sir.
remember this one. Okay, so fuses are used mainly to break the circuits when there is larger currents, right? So
Yes,
to
sir.
protect the devices for excess amounts of voltage or current, right?
Yes, sir.
Okay, that is the main purpose of the fuse. Okay, what is the remaining? What is the second point? The home circuit is nothing but parallel. Okay,
Yes, sir.
so many fuses are visible in homes. Why they are used? Because we will be separating some devices so that we can divide the current, right?
Yes, sir.
So the devices which are having or which use less current will be in one circuit, right?
Yes, sir.
The devices which use more current will be separated. So AC, geysers, they are separated from the fans, tube lights, or any other similar devices which use less current. Okay,
Yes, sir.
that is the reason why you can see many of nowadays they are not using fuses, but these are called MCBs. What they do is, if fuse is blown away, you have to replace that wire. Removing
Yes, sir.
that fuse carrier, you have to place the wire, right?
Yes, sir.
But here, what this MCB will do is, if current is more, simply they get switched off, right?
Yes, sir.
So replace the faulty device, or wait for the current that will go down, right? And
Yes, sir.
then you simply switch on that MCB.
Yes, sir.
Just push up that. Okay.
Yes,
So if
sir.
that circuit gets sorted out or current gets reduced, then it will switch on. Otherwise, it will be in off position only, so that we can protect our devices. This is called main circuit breaker, MCB, right?
Yes, sir.
So it will break the circuit when there is excess current or voltage.
Yes, sir.
Either way, it will serve. So voltage increasing means current gets increased. Why? Because device is not changed. If device is changed, current also changes, right? But
Yes,
not the
sir.
voltage.
Yes, sir.
Why there is no change in the voltage? Because the circuit we are using in our homes is parallel combination, right?
Yes, sir.
So whatever the voltage in the at the main board or main supply, that voltage is continued till the end or to the all devices. So the device in our homes, we are getting around 220, right?
Yes,
Or
sir.
200 to 240 volts. That is the rating. So we receive, most of the time we receive 200 to 240 volts, right?
Yes.
So what is the voltage? Highest voltage that the device will be operating? 240 volts, right?
Yes, sir.
If more than 240 volt comes into the circuit, what will happen to the device? Definitely the device gets burnt. So to avoid that one, we are using nowadays MCBs. In olden days, we used to use, or we used to have fuses, right?
Yes, sir. Fuses are still being used, no, sir? Rare.
Not, yeah, in especially in smaller devices, right?
Yes, sir.
Not in much place. In homes, they are not used now.
Yes, sir.
Suppose you take electric heater, sorry, iron, right?
Yes, sir.
Electric iron.
Yes, sir.
It will be having some fuse. Suppose you take spike suppressor, right?
Yes, sir.
To connect the PC or laptops, or we use some big, which will be having 4 or 5 sockets, right?
Yes, sir.
That one will contain one fuse, right?
Yes, sir.
So what is the purpose of that fuse?
To
Because we
stop
know
that
that,
device from
yeah, to protect the devices that we are going to connect, because they will be using less currents, right? Sometimes
Yes, sir.
more current will be coming through the circuit, home circuit, to avoid such surges. But nowadays, what is happening, another protection also we are having at our homes. What we are using now, most of the time we are using inverters, right?
Yes, sir.
So this inverter itself is having that protection, right?
Yes, sir.
Whenever from outside or from the transformer we get more voltage, automatically that inverter reduces the voltage, right?
Yes, sir.
So now the use of that fuses is getting reduced. Now we are not using much of these fuses. In olden days we used a lot of fuses. Almost every 10 to 15 days we used to replace fuses, because sometimes we used to get more current. Not only that one, our distribution system, right?
Yes,
Whatever
sir.
current or voltage that is coming from the transformers is nowadays it is highly stabilized, right?
Yes, sir.
In olden days it used to fluctuate from 150 to 240, but now we are getting almost 200 to 240 in between. So you, if you want, you can check it. And not only this one, we are using inverters nowadays. Almost all, everywhere we are using inverters. What they do is they are having built-in stabilizers.
Yes, sir.
In olden days, many of the people were used these stabilizers to connect TVs even.
Yes, sir.
They have a stabilizer in front of the TVs in olden days setup. Do you have any such, you have any
No, sir.
chance of using or looking at the stabilizers?
No, sir, but we used to have a big TV, sir.
Big TV now,
Like a
but
bulky one.
not that one I am asking. The stabilizers in olden days, if you ask your father, definitely he will tell about the story of the stabilizer,
Yes, sir.
right?
Yes, sir.
If you purchase a TV or if you purchase a fridge, do you have any stabilizer for the fridge now?
No, sir.
No. But in olden days, definitely that fridge should be having that stabilizer, even for the TV. For TV, one stabilizer, for fridge, one stabilizer. If I am wrong, if I am not wrong, you can ask your father, right?
Yes, sir. Probably it would be so expensive, sir.
Yes,
It would be expensive, no, sir.
not expensive. The distribution, whatever the voltage that was coming from the transformers, olden days transformers, was so much of fluctuation, right?
Yes, sir.
That voltage was varying from 150 to 200 or 240, sometimes 260, sometimes 270. That much of fluctuation we were, right?
Yes.
But now the distribution itself got better and better and better. Now we are getting almost highly stabilized voltages, 200 to 240 only. That is very little of variation, right?
Yes, sir.
So to get such stabilization, what they were using, that also we were discussed. The same thing, electromagnetic induction. What
Yes, sir.
that stabilizer will be having? It will be having It will be having a huge coil with lot more number of,
Solenoid.
right? Yeah,
Yes.
just like a solenoid. Okay.
Yes, sir.
It is nothing but the solenoid, right?
Yes, sir.
So whatever the stabilizer that were used, they contain only the solenoid. At one end, they will be having less number of turns. At the other end, more number of turns. But there was a protection. If current suddenly increases, they will go to the less number of turns coil, right?
Yes, sir.
So these are called another protection is nowadays they are also used. They are called relays, right?
Yes, sir. I heard about this.
Relay. But you will learn a lot more these things if you go to engineering, right? Especially electrical branch or electronics branch.
Yes, sir.
So this is just get some thought, observe what exactly happening, and then have more number of questions, then you can understand better, right?
Yes, sir.
That is possible with this activity because you didn't played with this activity. That is the main reason.
Yes.
Okay,
Sir.
if you have played with this one, then you might have answered all those questions, right?
Yes.
Because this is the advantage, because you can increase the voltage. What is the voltage you can increase up to, right?
Yes, sir.
120 volts. It blew away, right? As I
Yes,
increase
sir. It
the
broke.
voltage. Why? Because when voltage gets increased, what will happen? Current
It will break,
gets
sir. The fuse will
increased.
break
Current
because
gets increased. Once current is increasing beyond the tolerance of that fuse, it can't tolerate more than 4 ampere or 0.9 ampere that I specified, right?
Yes, sir.
So I have to remove and then I have to replace with the new fuse. Okay.
Yes.
So I have to take a new, right?
Yes, sir.
Okay. So now what is the current rating for the fuse? 4 ampere, right?
Yes.
Now I increase the voltage. Now you can see up to which voltage that fuse can tolerate. Almost 40 volts, right?
Yes, sir.
Okay, so after 40, so if you play with this one, then that will be easy for you. So more the observation, more the understanding. Why? Because more the questions, right? More the thought.
Yes, sir.
So get used. You played this one or not?
No, sir. I still did not.
Then why? Plenty of options are there to play, right? Even pencil, you can play with the voltages, you can play with the batteries, right?
Yes, sir. I will be doing that.
So now how much voltage this battery can offer?
1,000 years.
Yeah, 1000, right?
Yes, sir.
Even more than. Okay.
Yes, sir.
So there are such possibilities. So this is normal battery. Okay.
Yes, sir.
This can provide us up to 120 volt,
120.
right?
Yes, sir.
So this battery can work
100-volt battery. Like more than 1,000.
100 to
1,000.
110, 120, 130, 200, right?
Yes, sir.
So increasing in the steps of 10, right?
Yes, sir.
70, 80, 90. So you might have played with them. What is the current? How much current that will be flowing through, right?
Yes, sir.
Okay, that is the only thing for home circuits. Okay, anything left in that one?
No, sir. We are done with the chapter.
Got it?
Yes, sir.
So the purpose of the fuse, but nowadays we are almost that fuse is not used. MCBs are used. Some in some of the devices we are internally there will be some fuses, right?
Yes, sir.
Suppose now take a big TV even. The big TV inside of that one, there will be a stabilized inside of that one. They are putting all of these. That is why we are unable to see the stabilizer or these fuses. Instead of, if you open the TV, you can find some fuse in that, right?
Yes, sir.
But instead of the fuses, having another one. These are the coils, induction coils they are using.
Yes, sir.
Because the transformers nowadays also they are using a different types of transformers. Because in olden days the transformers were so huge, so bulky, so much of weight they used to have. But now they are having, suppose you take the charger, mobile charger, right?
Yes, sir.
If possible, you find any old type mobile charger, you just compare the weights.
It will be bulkier, sir. Naturally.
Why? What is the difference? You ever
Stabilizer.
try to identify the difference? Why the old chargers are bulky?
Sir, because they are not.
Yes?
Because they need to stabilize more, sir.
No.
More parts.
No. That's not the one. In previously, they used to have the metallic plates. Around the metallic plates there were windings. That was the
Oh.
transformer, right?
Yes, sir.
But nowadays they are not used. No way. No instrument nowadays they uses these bulky metallic transformers. You want to
Yes.
see them,
Yes,
right?
sir.
Transformer. You ever saw that transformer?
Ah, yes, sir.
Yes.
One is outside our house.
Inside of this one.
Oh,
This is the basic structure of transformer. These are the metallic plates, right?
yes, sir.
Okay.
Yes, sir.
Metallic plates. One side you will find more number of turns, other side you will find less number
Yes,
of
sir.
turns. We already identified that if number of turns is more, definitely the current will be more, right?
Yes, sir.
We experimented this one because induction will be more. If larger the number of turns, larger
More
the
current. Yes,
right?
sir. Yes, sir.
This is called, suppose I give some voltage towards this side. Are you able to see the cursor?
Yes, sir.
This side, right? If I give the voltage this side, what about the current this side? Increased or decreased voltage I get?
Increased.
Increased voltage. This is called step up, right?
Yes.
This is called boosting also.
Yes, sir.
This transformer, whatever the substation you might have heard, you heard the substation? Hello?
No, sir. No, sir.
No. If you have the chance, then you can read some of the plates. 33 by 11 kV.
Ah, yes, sir.
220 by 11 kV. Like this, there might be written something. What exactly this one is? From 33 kV, the substation is getting reduced to 11 kV through these transformers, right?
Yes, sir.
Okay, transformers are used everywhere, but these transformers contain the metallic plates. But the mobile chargers, now previously they used to have these type of transformers even in the mobile chargers, small chargers, right?
Yes, sir.
If you cut open that old mobile charger, you can see these type of transformers, right?
Yes, sir.
But nowadays, no charger is having this type of transformers, right?
Yes, sir.
Okay, what are those new transformers?
You I
These are the transformers nowadays.
they
They are
are
using
in charges.
this one.
These are in charges. Sir.
Yeah, if you cut open the new mobile chargers, you will find the transformer or the coils like this. These are called toroidal transformers, right?
Yes, sir.
Okay.
Yes, sir.
Are you able to see this picture?
Yes, sir.
These are the coils, right?
Yes, sir.
These are the old one.
Yes, sir.
Charger transformer, 220 volts and right?
Yes, sir.
But now single phase 2 ampere mobile transformer, right?
Yes, sir.
You got it?
Yes, sir.
This is the circuit board. You will find a coil like this.
Yes, sir.
In olden days, they used to use the metallic core, but now they are not using these metallic cores, right? This is the
Yes,
metallic
sir.
core. They are not using now.
Yes,
They are
sir.
just using the toroidal coils, right?
Yes,
Do
sir.
you find any such thing in this board? Do you
No,
find
sir.
any such thing?
No, sir.
But you will find a coil like this, right?
Yes, sir.
Okay. So now even very small coils, they do the job. This one, right?
Yes, sir.
So as the technology gets improved, yeah, this is very good example of olden days transformer, right?
Yes, sir.
Now they are get rid of that. Yeah, now this is the coil.
Yes, sir. It's smaller.
High frequency transformer for mobile charger, right?
Yes, sir.
Now the technology has changed.
Yes, sir.
Just use the idea that I'm giving, search through the information, have some questions, and then plenty of information is available, right? The thing
Yes,
is,
sir.
you should have a good set of questions and good idea how to search, right?
Yes, sir.
Got it?
Yes, sir.
So in olden days, they used to have bulkier or bulky transformers.
Yes.
Now we are shifting to higher frequency charging.
Which is smaller.
That is a different way of charging the devices. But old transformer cannot charge the new mobile. Even that keypad mobile, you might have seen.
Ah, yes, sir.
That charger can charge the new mobile.
No, sir.
No. Can the new mobile charger charge the olden days that keypad phone?
No, sir.
Not vice versa. They cannot, right? This technology is different. That technology is different, right?
Yes, sir.
Yeah. Anything left? Any more information you want regarding any other topics?
No, sir. We are clear.
Okay. So not only now, whenever you find any doubt or difficulty, if you want to have some discussion, you can, right?
Yes, sir. Sir, those worksheets, sir.
Worksheets, I think Sir told that he is going to hand over. You have the number?
Oh, yes, sir. I'll talk to sir. And
Yeah, just you make a call to him. He is in Hyderabad itself.
yes, sir.
Okay, maybe tomorrow I think he may be busy because to yesterday and today he may be in the meetings.
Yes, sir.
Maybe he might have completed now. Maybe night or tomorrow he will get, I think. Otherwise, after half an hour or so, you try to contact, right?
Sir, otherwise one lesson ka sample you can send us, sir. I'll finish it and we can clarify doubts tomorrow.
Otherwise, I have PDF files. Can I share with you?
Yes, sir. One chapter you send, sir.
That not chapter wise. That is a complete one PDF file for one subject.
Which subject, sir?
I just wait. I will check whether there is. So that if that is the case, I will share now itself. Okay.
Yes.
Just wait. Yeah.
Maths is enough, sir. Only one chapter. And tomorrow I'll take it.
I think otherwise I do one thing. Do I have them? Yes, I have. Okay, what is your
Email ID, sir?
just wait. I open the mail.
Yes, sir.
Okay, what is the mail ID?
PISHYAVARDHAN. Like no
V?
space. VARDHAN.
AN, right?
At the gmail.com. Yes.
Am I correct?
Yes, sir.
Okay, because I am already having these PDF files.
Yes, sir. I'll start doing. If those workbooks come, I'll write off in that.
Okay.
Okay, sir.
Okay. So
Yes, sir.
check your mail
Checking.
and let me know. Received?
Yes, sir. 1 minute. It will take some time. Yes, sir. Got it.
Just download them.
Yes, sir. I'll download them onto a pen drive.
Yeah.
After class, I'll download.
Yeah, you can download and then you can take the one chapter printout. Meanwhile, you will be receiving them, right? You don't
Yes,
take all
sir.
the printouts, right?
Otherwise, we can't be waiting for the.
Yeah, whichever the topic you want, just you take printout of that one only, right?
Yes, sir.
So finish it off. If you want to share some of the results, and then you can take the screenshot and share.